All right, so we're on DOK3, and we're on the last bullet. We're on the third. We're on the third bullet point of the first bullet point. Lena has a job offer with an initial salary of 29,000, with a percent that is going to be your rate of 4%, and increase yearly. And pretty much this is a growth factor of 1.04. So this is what we care about. Okay? So when we put it in our equation, it's going to be 29,000 times 1.04 times T. Okay? All right, next bullet point. A culture bacteria starts with 50 and increase exponentially at a growth of 10. Create an equation to model this. So that's y equals AO times R times T, which is going to be 50 times 10 times T. Now sometimes T can be X or T. They both mean time. All right, so for the previous problem I used T. This problem I'm going to use X. But it means the same thing. How many days will bacteria reach at 800,000? So technically what we want to do is we want to solve for T. Okay, so we're going to do the Y equals the amount after the rate. So what they're saying is if it reaches an amount of 800,000, what is going to be the time for that? Okay, so what we're going to do is we're going to plug in 800,000 for Y and solve for X. Okay, but for me, all you have to do is just show me the equation. Okay, so it's just going to be 800,000 equals 50 times 10 to the X. And then you'll divide 50 on both sides. $800,000 divided by 50, that's 16,000 equals 10x. Then you're going to take the ln. Here, let me put this in the equation lab so you can see it. So we're going to solve for x for the equation 16,000 equals 10 to the x. Okay, here we go. All right. Yep, so I was right. Yep, so you're going to go ahead and take the ln of both sides. So whenever you take the ln of an exponent, the exponent comes out in front of it. So it just moves out to the front, and then you put an ln in front of it. So then now you have the ln of 16,000 equals x times ln of 10. And you're going to solve for x by dividing the ln of 10 on both sides. X equals, put this in the calculator, ln of 16,000 divided by the ln of 10. So that's 4.2 days. So that's how many days it takes for it to go from 800,000, from 10 to 800,000. I mean, excuse me, 50 to 800,000. It takes 4 days. So that's the growth of it. All right. A half-life radioactive 14 is 45,730 years. In other words, half of the given amount is remaining is 5,370 years. How much of the 16 grams will be remaining after 500 years? You don't have to do this problem because I won't be grading on that one. So you can skip that one. All right. So we're going back to the previous problem in the equation. As y decreases when x increases and y increases when x decreases, what kind of relation best describe this? So this is the equation up here, okay? So you can see that because it's negative, you see that when x goes up, the y should probably go up as well. It means go down, okay? We can test that from looking at decimal. So we have y equals negative 4x plus 3, okay? So you can see that when the y goes down, the x is going up. So you can see as we increase in the x, the y is going down. So that is called an indirect relationship. So for this part here, it's an indirect relationship. All right, in the equation, y decreases and x decreases, y increases and x decreases. What type of relationship is the second one for that one? So this is the slope of 3 and the y-intercept. So if we put that in decimal, we have a slope of 3 and the y-intercept is 2, I believe. Yep. All right, so we see that as the x gets bigger, the y also gets bigger. So that is a direct relationship. So when x goes up, y goes up. Okay. Explain the effect of x of y in the equation y equals 5x. Okay. So if we just plug that into decimal, right? So we see that when x gets bigger, the y goes up. So that is a direct relationship. Which of the following equations is an example of a direct relationship? So a direct relationship is pretty much when you have an equation where the independent variable is on the same line as the dependent variable. So for example, if I draw a line of that, these two are on the same line. They're in the numerator. Compared to if I had 3 over x, these are not on the same line. So this is called direct, and this is called indirect. Okay, so that means when y goes up, x goes up, or when x goes down, y goes down. Vice versa, when y goes up, x goes down. When x goes up, y goes down. Okay, so all you're doing is looking for the variables to be in the same column. Excuse me, row. And if it's in the same row, that means it's direct. If it's not in the same row, that means it's indirect. So you see that this is indirect, this is direct, and this is also direct because it's going to go up at the same time because this is an exponential growth. All right, so this one is indirect, direct, indirect. Which of these situations represent an inverse relationship? This is inverse because the x is at the bottom. This is direct because the x is at the top. Even though there's a fraction, the x is still a numerator. And this is also a direct relationship because this is exponential growth. All right. Okay, and so there you go.